Chapter 17, Video 2, Greenhouse Effect. The greenhouse effect is caused by atmospheric trace gases that reduce the rate at which the Earth gives off infrared radiation. Without the natural greenhouse effect, the average global temperature would be somewhere around 1.4 degrees Fahrenheit or -17 Celsius. In recent Earth history, a relative steady-state balance has maintained the average global temperature of about 59 degrees Fahrenheit or 15 degrees Celsius, which has allowed life to flourish on the planet in multiple locations. Greenhouse gases in the atmosphere allow the energy from the sun to come in, shown on the left, but trap and reflect much of the lower energy infrared radiation or heat from the sun's surface on the right. So on the left side, energy is coming in the form of light and high energy radiation. When that radiation hits the surface of the Earth, it's reflected back as lower intense energy or longer wave radiation called infrared energy, as we know as heat. As the heat rises off the surface of the planet, it runs into some gases that reflect it back toward the Earth and keep the atmosphere warm. Without these gases, all of that heat would be lost into space. The best known greenhouse gas is carbon dioxide. However, water vapor plays a major role as well. In addition to naturally occurring carbon dioxide, there are the CFCs we mentioned in the first part of the chapter, methane, natural gas, and nitrogen oxides produced from burning fossil fuels, as well as some natural sources. A small amount of atmospheric CO2 is essential for life on Earth. Without it, too much energy would leave the planet's surface, and it would be too cold. Also, plants need CO2 to make sugars from sunlight during photosynthesis. Atmospheric CO2 has been increasing steadily as a result of human activity, namely of burning of fossil fuels. So since the Industrial Revolution, the concentration of CO2 in the atmosphere has been going up quite a bit. The major increase in atmospheric CO2 is from the burning of fossil fuels such as coal, oil, and gas. Additional CO2 is emitted through deforestation, because if you lose your forest, then you're not taking CO2 out of the atmosphere, both through the burning of wood and decay of wood and the loss of trees, which can remove excess CO2. This shows the wood burning emissions from fossil fuel from 1950 to 2004. Over the last 2 centuries, humans have released massive amounts of carbon that have been out of atmospheric circulation for millions of years. Carbon emissions from the burning of fossil fuels are produced disproportionately by the industrialized nations. For example, in the US, we produce nearly 20% of the world's CO2 emissions, while containing less than 5% of the world's population. Carbon dioxide is responsible for about 50 to 70% of the current abnormal global warming. Other greenhouse gases that play a significant role are CFCs, we talk about, methane, and nitrogen oxides. Shut up. While other greenhouse gases are present in much smaller amounts than CO2, they are more effective in trapping the Earth's heat radiation. So is the Earth warming up? Over the last century, there's been an increase in the atmospheric temperature in the Earth's surface. Other data which support this trend are ocean surface temperatures, geophysical borehole temperature patterns, and the retreat of non-polar glaciers. At the present time, the Earth is heating up more than 10 times faster than it did at the end of the last ice age, some 10,000 years ago. Averaged over all land and ocean surfaces, temperatures warm roughly 1.5 degrees Fahrenheit from 1880 to 2012, according to the International Panel of Climate Change. This might not seem like a lot, but we're talking about the entire surface of the planet changing by 1 or 2 degrees, which can have huge effects on local climate and how much water is in ice form or aerosol versus liquid form. So how much is the Earth going to warm up? Continued addition of these so-called greenhouse gases to the Earth's atmosphere will unquestionably warm up the planet. That said, global dimming may actually be staving off more intense global warming because, in addition to CO2, other particulates are going up into the atmosphere, blocking some of the sun from reaching the Earth's surface. Many researchers have concluded a doubling of the atmospheric CO2 will lead to an average global warming of 2.3 to 8.1 degrees Fahrenheit. The United Nations Intergovernmental Panel on Climate Change is continuing to study this problem. Now, historically, there's been a lot of fluctuation on the Earth's temperature. The Earth's surface temperature fluctuated throughout history, can be measured in ice cores from the poles and sometimes in the geological record. During the Pliocene, that's our current time, ice ages occurred in about a cycle of 100,000 years. We're not quite sure what influence changing the greenhouse gases will have on this pattern. You can see that a drop in the average temperature on the planet of 5 degrees Celsius correlates to the last ice age. Over the last 10,000 years, the mean temperature has been very stable. Until about 1970, when the concentrations of greenhouse gases got past a certain crucial point and the climate began to rise. From this line to this line is 1 degree. And from this number to this number is about 1.5 degrees, which is where we've been measuring for. And this is the change since the Industrial Revolution. Predictions are hard to make based on the number of variables, but we can certainly see that there's an increase over time here. Most models show an exponential increase as the level of CO2 goes up, and we're not quite sure what is going to happen when this does. It could make everything hotter. It could also throw us into another ice age. This whole area in here is a great area of intense research and prediction from climate scientists. But it's very hard to do with so many variables. That said, several factors contribute to the uncertainty in predictions about global warming. There can be imprecise data coming from many sources. There can be different circulation models that we use to try and predict what's going on. And also, as I said before, the predictability of the next ice age. However, a vast majority of scientists who study the problem believe that global warming is a real phenomenon and will change the distribution of resources across the Earth. There's considerable uncertainty about the effects of global warming, and as yet no good way of testing the predictions. Probable environmental alterations created by global warming include changing climate and weather patterns, which some say we're already seeing, rising sea levels, which can be measured, and shifting climate zones causing the ecosystem devastation and species loss. Three basic approaches are available to address this problem. The waiting strategy, where we wait and see what happens, continue on our same course. The worst case scenario strategy, where we stop all global production of carbon-based CO2 pollution. And something in between, where we compromise and reach for middle ground. If global warming is real and takes place, the economic cost will be tens of trillions of dollars. Really, the only way to reduce this possibility is to reduce the fossil fuel use we use or add reforestation. There's some relatively weak action on international level through the 1990s. In 1992 at the Earth Summit, 160 nations signed the United Nations Framework Convention on Climate Change, the UNFCCC. And then in 1997, the Kyoto Protocol was developed and ratified in 2001, with 178 nations signing on. The United States did not sign the protocol, and neither did Australia. The Kyoto Protocol is an international agreement linked to the United Nations Framework Convention on Climate Change, which commits its parties by settling internationally binding emission reduction targets. Recognizing that developed countries are principally responsible for the current high levels of global warming gases in the atmosphere as a result of more than 150 years of industrial activity, the protocol places a heavier burden on developed nations under the principle of the common but differentiated responsibilities. So how do we combat global warming? The principal way is to cut down on CO2 emissions and provide additional sinks for CO2, such as increasing forest cover. Fertilizing the ocean is a possibility with limited nutrients to promote the growth of phytoplankton to absorb CO2, and perhaps injecting CO2 deep into the earth. Increasing energy efficiency and promoting the use of renewable forms of energy would also make sense. Other types of policy discussions revolve around carbon taxes that can be used where dirtier energies like coal would be taxed more heavily than cleaner energies like natural gas. This way, you account for externalities to the cost of using fossil fuels as well. Emissions permits would curtail the amount of carbon that companies could release and allow the trade of permits. So far, cap and trade policies have been rejected by the American people, but are used elsewhere in the developed world. In addition to global warming, other things that occur on a global scale are things like light pollution. Light pollution is extra waste light by nighttime light sources. Light pollution can have adverse effects on humans, animals, and plants, messing with circadian rhythms and disturbing ecosystems. Most light pollution isn't taken as seriously as global warming, but it still has effects on life on the planet. In this section, we talked about what a greenhouse effect is and why it's important to life on the planet. We talked about the imbalance of greenhouse gases and how people on the planet are affecting it. We also looked at the historic data back to the last ice age and scientific projections and what they say about greenhouse gases and climate change. We want to understand why it's difficult for all scientists to agree on what's happening in relation to greenhouse gases and global warming. Scientists are often used to dealing with uncertainties, but policymakers don't like them, and often they get twisted for political advantage in the society. Consequences for climate change are pretty grim. Some people near the equator are already seeing the land that they live on sink into the ocean as the water rises around them. We have some tools to address this climate change, but not enough. we need to care about what's going on with light pollution as well. This is a new area, and not much work is being done.